This is 10.6 part 2, and 10.6 part 2 deals with secants and tangents that intersect outside the circle. So we're going to take a look at 3 cases. One case is 2 tangents, the second case is 2 secants, and the third case is 1 tangent and 1 secant. So as you can see here, we have 2 tangents. Here's a tangent, here's a tangent. And notice that the tangent intersects in one spot. And here's 2 secants, secant and secant. And notice that the secants intersect at 2 spots. And here we have a combination of tangent and secant. Notice that the tangent intersects at 1 spot and the secant intersects at 2 spots. Right? So those are the 3 we're going to be taking a look at. Now I want to take a look at the 2 tangents case first. Here I have a diagram with a circle with 2 tangents intersecting on the outside. Now I'm just going to make up an angle measure, and we're going to fill in these angle measures into this 3-column table and see if we can find some kind of a pattern. So I'm going to start with an angle measure of 20 degrees for angle A. Okay. And then let's say I'm asking you, what is the measure of that arc? So it might look like I haven't given you enough information, but I actually have. So let me show you what you could do. First of all, if I draw a radius to the tangent, to the point of tangency, remember that the radius is perpendicular to the tangent at the point of tangency. So I know that this is 90 degrees. Now, let's say I do the same thing on the other side. So I have 90 degrees. Now notice that I have created a quadrilateral. And in my quadrilateral, I have 90, 90, 20, and then something. Now, a quadrilateral, you know how a triangle, the angles add up to 180? In a quadrilateral, the angles add up to 360. Okay, so I already have 290s, so that's 180. So therefore, I have another 180 left for my 20 and this mystery angle. So if I take 180 and I subtract 20, that will give me my mystery angle, and that's 160. And notice that angle O right here, this 160, is a central angle. And because that's a central angle, the angle measure is the same as the intercepted arc. So I have figured out, just by drawing a quadrilateral, what that arc is. So I'm going to fill that in. So this is the little arc that I've just figured out, and that's 160. That's what little arc means. Now, let's take a look at what the big arc is. Now, the big arc is this other arc. I'm just calling it big arc and little arc instead of minor arc and major arc, just to keep it simple. So the big arc, well, I know that the little arc is 160. So the big arc is 360 minus 160, which is 200 degrees. Okay, so here I have filled in 3 numbers, and I'm not going to ask you what their relationship is right now because it might be hard to tell. So let's do another example. So let me get rid of all this stuff. Okay. So I'm going to make up another angle for angle A, let's say just randomly 70. Okay. Now, again, this is 90. This is 90. So what's left for that angle? Well, Again, quadrilateral, the angles add up to 360. The 90 and 90 is already 180. So that leaves us with 180. And then take away 70, and that gives me 110. So therefore, since that's a central angle, the intercepted arc is also 110. So my little arc, or the minor arc, is 110. Okay. Now to get the big arc or the major arc, we do 360 minus the little arc, and that gives us 250. So this is 250 over here. Okay. Anybody seeing a pattern? I don't know. Maybe you might want to pause the video. Up to you. I'm going to do another example. Let's say I have 50. Okay, 50, so that's 90, that's 90. I'm sure some of you are already not even bothering with those 90s, and you're just doing 180 minus 50 at this point. 180 minus 50 is 130, which means this is 130. And 360, oops, 360 minus 130 is 230. Okay. Now what I want to do, don't worry if you haven't figured out the pattern, that's okay. What I want to do now is, instead of giving you the measure of angle A, I want to give you a measure of the little arc or the minor arc. So let's say, let's use one that we haven't used yet. How about 100? So if this is 100 degrees, then the central arc is 100 degrees. I know that this is 90 and this is 90. Sorry, this is 100, not 108. Okay, so what's left for angle A? Well, I'm sure you guys already are doing this really quickly, and that's 80 degrees. So I have 80 here, I have 100 here, and 360 minus 100 is 260. Okay, I'm going to do one more. Let's say this minor arc was 132. I don't know, doing something different. So again, we have 132 here, and 180 minus 132 is 48. So I have 48, 132, and then 360 minus 132 is 228. All right. So I don't know if you guys have been able to figure out what the pattern is here. I'm going to kind of show you. I'll get you started. So what I'm going to do is I'm going to take the difference between column 1 and column 2. So the difference between 200 and 160 is 40. So I'm just going to put the 40 over here. Okay. And the difference between 250 and 110 is 140. And the difference between 230 and 130 is 100. Are you guys starting to see a pattern between these numbers here? The difference between 260 and 100 is 160. The difference between 228 and 132 is 96. Is there a pattern between what we're getting as a difference and the measure of angle A? Well, I hope you figured out that if I subtract the big arc minus the little arc, and then divide that by 2, you're going to get the measure of the angle that's on the outside. You're never going to have a case of an angle being on the outside where it's intercepting an arc that is 180 degrees. It's impossible. And as you can see, the big arc minus the little arc is 0, and therefore the angle out here is 0. In other words, it's impossible. And as you can see, why it's impossible, because the tangents will never meet. Now, I know you guys, one of you would have asked me this question, which is why I put it out there. By the way, this is Geometer Sketchpad. If any of you are interested, I did send you a copy of it. I don't know if any of you tried to download it. I don't know if it's working. But this is Geometer Sketchpad if you want to try it. It's a little bit tricky. I'm still not quite there with it, but I'm trying. So here I have a case of two tangents that are intersecting circle and on the outside. And the outside angle is 20 degrees right here. And the two arcs are 200 and 160. And notice that 200 minus 160 is 40, and divided by 2 is 20. Okay, and down here I have a running total. Big arc minus small arc is 40, and then therefore the angle is half of that, which is 20. So I'm going to move this around. All right, as you can see here, we have 28 as the angle on the outside, and the two arcs are 208 and 152, and 208 minus 152 divided by 2 is going to be 28 if you do it on your calculator. As I move this around, watch the numbers change. Some of them it's rounding to the nearest whole number, so it might not look like a half to you, like right here. It's not looking like a half, it's looking a little over a half, but that's just because of the rounding. It is actually a half of the difference. So here's 52, the difference, and right here, 52 and 26. So watch those numbers. And as I move this thing around, as you can see, as the difference between the big arc and the little arc change, the angle on the outside, angle F, is half of the difference. Okay, I want to move this in here so you guys don't get confused. So here we have a case of two secants. And this is the reason why I didn't call the arcs major arc and minor arc, because as you can see in this case, right over here, this is a minor arc. And right over here, this is also a minor arc. Now, to find this angle that's on the outside for two secants, what you do is basically the same thing, but you ignore these spots on the outside, these arcs. All right, so we're going to ignore those. We're going to pretend they're not there. And we're only going to be looking at this arc 71 and this arc 31. Again, big arc minus little arc. So let me show you 71 minus 31 is equal to 40. And that's what this 40 is referring to, the difference in arc measures. And then 40 divided by 2 is equal to 20. And that's this angle that's on the outside right here. So I'm going to roll these along again and show you that, again, the relationship is the same, very similar to the tangent situation. So if you watch this right here, you'll see that no matter where I go, the situation stays the same. Here's another situation, 66 minus 36 divided by 2 is 15. And here's a situation with a secant and a tangent. And as you can see, we have big arc and little arc, not necessarily major arc and minor arc, because as you can see, both of these arcs are minor arcs. They are both less than 180. And in this case, we have 164 minus 128, and that's equal to 36. And when we divide that by 2, we get 18. And that's this. So again, it's arc minus arc divided by 2 is equal to the angle on the outside. And again, it's big arc minus little arc divided by 2. Okay, or you can look at it as the difference absolute value, because we don't want to get a negative. That's why it's big minus little. If you do little minus big, that's okay too, as long as you take the absolute value, as long as you don't make it negative. Number 1 is asking you for the measure of angle 1, which is the measure of the outside angle. So again, I'm going to take big arc minus little arc divided by 2. 80 minus 40 is 40. And then divided by 2, that's 20. So measure of angle 1 equals 20 degrees. This is degrees, okay, not length. All of the questions here are dealing with angle measure and arc measure. Everything is in degrees. Let's go on to number 2. Number 2 also is asking you for the angle on the outside, but this time, unlike number 1 where we have 2 secants, here we have a secant and a tangent. We have 80 degrees here, we have 160 outside. Now remember, these two arcs are separated by this intersection of the tangent. And here, this arc right here is created by the secant and the tangent. All right, so big arc, 160, little arc, 80, divided by 2. That's 80 over 2, which is 40 degrees. So measure of angle 2 equals 40 degrees. Here we are on the next page, number 3. Number 3 is asking for the measure of angle 3. And all I'm given here is that this big arc, well, this time it's a major arc, is 220. Now, here we have 2 tangents intersecting, which means that we're dealing with the entire circle. So first I have to figure out what the arc inside is, what this one is. So I'm going to do 360 minus 220, and that gives me 140. So I know that this right here is 140, which means that 220 minus 140 divided by 2 will give me the measure of angle 3. So measure of angle 3 equals 40 degrees. I'm going to move on to the next one, number 4. This time they are asking you for the measure of arc JP. That's this right here. Okay, so this time we have 70, I'm going to call this x. 70 minus x divided by 2 has to give me 20 because that's the angle R. So in this case, what I'm going to do is multiply each side by 2 to remove that 2. So 70 minus x is equal to 40. Subtract 70 from each side. Be careful here. Negative x is equal to negative 30. Therefore, positive x is equal to positive 30. And that's degrees. So measure of arc, JP, like that, is equal to 30 degrees. So here we are on number 5. Okay, now in this case, this is one of those cases where it looks like they've given you absolutely no information. They've given you the angle on the outside is 50, and they've given you nothing else. But this is a case of two tangents, so we actually do have enough information. If you draw in two radii, just like we did at the beginning of the lesson, we know that the radii are perpendicular to the tangents at the point of tangency, and those two angles have to be 90 degrees. So that leaves us with 180. So I'm going to take 50 away from 180, and that gives me 130 degrees. So I know that this arc is 130 degrees. Also, the central angle is 130 degrees. Now, the question is, they're asking for measure of LN. Now, which LN is it? Is it the little arc or the minor arc, or is it the major arc? Now, the major arc would be over here. Which one are they asking for? Well, unless they name it with 3 letters, like let's say LKN, then we're always looking for the minor arc. So measure of LN is equal to 130. Okay. Let's move on to number 6. So here I have a whole bunch of angle measures, a whole bunch of arc measures actually, and we're looking for the measure of angle V. That's this angle right here. All right, so I know that the big arc is 100, but I don't have the little arc. So how can I find that little arc? Well, as you can see, most of the degree measures in the circle have been filled in. So all I need to do is figure out what that angle is. So I have 360, and I'm going to take away the 110, the 100, and the 80, and figure out what's left. So as you can see, this is 180 already. So you could probably just do 180 minus 110, but I'm just going to do the whole thing. 360 minus 110 minus 100 minus 80, and all of that is equal to 70 degrees. So I know that right here I have 70 degrees, right? So this is what I need, the big arc and the little arc. The big arc is 100, the little arc is 70, and I'm going to divide by 2. That gives me 30 divided by 2, which is 15, which means that the measure of angle V is 15 degrees. All right, so I hope that this was helpful to you guys and that you're able to do your homework. If you have any questions, as usual, feel free to email me. All right, see you guys in the next lesson.